Hello, and welcome to another live software design simplified live stream. I just kind of lost my words there for a moment. We've got Jake on the line here. We are going to look at a rather unusual little challenge today, which is this code base written in Go. And we're going to do some refactoring, and we're going to change the behavior of the system, and we're going to see how we get on. I know literally nothing about Go. This was submitted by somebody who's a watcher of the stream, Byron. Now, I did ask Byron to come on today, but it doesn't look like he's shown up. So sorry you couldn't make it, Byron. Here's the video to show you what we're going to be doing today. So this is, of course, live streamed over the internet. And if anybody is wanting to watch it back, hopefully this will give you some value. So what actually is all of this stuff? So this is in this IDE called GoLand. And it's an IDE made by JetBrains. And we've got a whole load of files. It's quite a big project. And it's an API. And you can hit these API endpoints with various requests, and it does purchase orders and quotations and signing of petty cash orders and all this kind of stuff. So it's a paperless office. Sample Corp Paperless is the name of the project. And what we have is a payments.go, and in this payments.go, if we can find it, there's a to-do that says check if you use admin. So there's this function here called approve payment request, and if we search the code base for this, there's some test queries there. This is the function that we're just looking at here. And somewhere it should actually call this. Here we go. So it routes this post request, payment request / approve, to this method here. And this is the behavior change we're going to make to check if the user is admin before we approve the payment request. What questions do you have so far, Jake?
None at the moment. Just seeing how this pans out and maybe ask a few more.
Okay, cool. So we have all of our tests in this, we can run them in this API test configuration here. And so we're going to run that. Compiling. And annoyingly, that dialog comes up. I haven't figured out how to get rid of that. We've got 13 tests passing here. This is what tests passing look like in Golang. Okay. And in terms of tests for this payments.go, there is a single test for this API endpoint, which is test payment approval API approved for any user, which is interesting because we don't want it to be approved for any user. We want it to be rejected for any user who is not an admin. And let's just work our way through this test and try and figure out what's going on together. So one idiom in Go is that anything with a capital letter at the beginning is a public function, and anything with a lowercase letter at the beginning is private. So, and anything beginning with test that has this kind of testing signature here, Go will treat that as a test. So we can see we've got a whole bunch of these private methods And all of these are, it looks to me like they are methods that help this test do its thing. So in this whole file, we've got a single test with loads of these little test helpers. Okay. So what do we want to do? We want to make a payment request with no roles. So there's these things called user roles, and they determine, they determine what role a user is going to be, it has actually. So in the, if we just go back to the place where this was called, in here, we've got all these auth routes. And how does authentication work, you might wonder? Well, in here, we've got this use auth middleware, and then use server current user middleware. So do you know what middleware is, Jake?
Yeah.
Can you explain what it is for everybody in the audience, everybody watching?
My understanding of it is that it's software executed between the request and response.
Yeah, that's right. So very, very broadly speaking, broadly speaking, you would have a request come in, and that hits a controller, maybe. That's actually a relatively reasonable, relatively reasonable diagram, actually, generated by GitHub Copilot. Thank you, Copilot. And then the database hands it back to the repository, hands it back to the service, hands it back to the controller, and the controller renders a response back to the browser. So browser makes a request, and then it goes all the way back to the browser. And there's certain parts of this that may or may not come in. So you may not have a service layer, you may not have a repository layer, but broadly speaking, it would look something like that. Okay. And middleware is small pieces of software that are functional, sometimes with side effects, that sit around about here. When the browser hits your app with a request, it will then go into a stack of middleware. And that middleware is executed before it reaches a controller. And also, it works the other way as well. Middleware is a kind of a two-way thing. So the way I like to think of middleware often is like a Russian doll. So you have these like 3 or 4 Russian dolls within one another. And middleware is another Russian doll that you're adding into the mix. So it's another layer that every request comes through. Why on earth is that useful? Middleware is great for cross-cutting concerns. What does that mean? It means something that every controller would have to do again and again and again. So the framework I have the most experience with is Ruby on Rails. And very often I see controllers in Ruby on Rails littered with authentication. So figuring out who the user is, figuring out, are they authorized, are they authenticated, who are they, what permissions do they have, all that kind of jazz. And that code is repeated across loads and loads of controllers, and very often there's these copy and pasted methods or mix-ins or whatever, and it all gets a bit of a mess, because at the controller level you're having to repeat the same code again, because of course there might be 20 or 30 controllers that all require the user to be admin. Instead of doing that, we can put some middleware in the chain, and this middleware can say, is the user admin, yes or no? And if they're not admin and they're not allowed to access the controller, it just punts it straight back to the browser. What that means is sometimes the middleware can even prevent it going any further. So what that means is your controller doesn't even get into the mix. It doesn't even hit your controller. It only hits your controller when you know somebody's authenticated and authorized to use your service, which is really cool. because your controller can stay nice and simple and you can handle this kind of authentication in the middleware. There are disadvantages too, of course. Now you've got to understand code in 2 places or more to understand your full system. But I really like middleware. It's also very easily testable because it's just one in, one out. It usually does something very, very minimal and small. Any questions about that, Jake?
No.
Yeah, okay. So I saw a rename file there, middleware. And I will include a few articles on middleware for those of you who are interested in it. Back to our use case here. We have this auth routes, and it says, helpfully in the comment, routes that require authentication. So if we look above it, you'll see the difference. We've got router.get, current user. There is some middleware here, but equally on these two, there isn't this current user middleware, and it's using the router directly. So what is the router? The router is gin.default. So we're using this server called gin, and it creates us this router variable, and we can define routes with get and post and put and all the rest of it. And instead of doing that, we can call group on router and then call use, and we just keep calling use with as many middlewares as we want. And that gives us a new object that still responds to get and post and put and all the rest of it. The difference is it's got to go through this authentication middleware to get there. So all of these authentication routes already have to be authenticated. You have to be a logged in user to use them. So it's almost like with this one, we want an extra bit of middleware. So that's kind of a little bit about middleware and authentication and how the app is set up. What I'm really interested in now, to be honest, is exploring how are we going to write a test that is going to log in as an admin, and the request is going to be an okay and do the whole payment. And then how are we going to log in as a non-admin, and any user basically, and make sure that it tells us 401 is probably what we want. So what do you think I should do first, Jake? Do you have any ideas about a good starting place for this here? Because this is kind of quite hairy. I'd quite like to use this almost like as a template for a test, but I want us to kind of write our first failing test ourselves from scratch, using this as inspiration.
I would start maybe by just writing a test, just an empty test at the moment.
Good idea. Yeah.
It looks like there's some stuff to set up, like on line 23.
Yeah.
Test server, that sort of stuff.
Yeah, it's a test server and a mock store. I like it. So let's do test payment request, test payment approval. I'm going to ignore what this says. Test. I'm going to do a kind of a given when then style, which is a style that I absolutely love. Given a user who is not an admin. Oh, look at that. It's just written it for us. Whoa. Okay. Let's just run that then, shall we? The wonders of ChatGPT and GitHub Copilot. Okay. Could not make request post. So it looked like it was right, but I don't think it was at all. So let's go through it. Set up test server and mock store. We can look into that in a second. And then we expect the store to be called with this method. And I believe that this is the object that it is stubbing out. So this is essentially mocking stubbing. Return. Oh, yes, of course. So it's returning in Go, I should say, Jake. They have this strange. Am I going to get lynched if I say strange? This quite strange style of executing code and dealing with errors. And every single function, not every single, but most functions return a tuple of two objects. The first object is the value, and the second object is the error. So if we just go into payments.go, come on, there's an example, right? Get user ID from context. And we see this pattern again and again in Go. You have the user ID, that shouldn't say int, that should be user ID, comma error. And so it's getting the user ID from the context, it's destructuring it into these two objects, and then it's checking if the error is not nil. If the error is not nil, it means something's gone wrong. So you put your error handling in here, and normally you return out or you crash or you do something. And then if it's all okay, you carry on, safe in the knowledge that this thing here contains the user ID that you wanted from the context. So in this case, we're saying get user by username or email, and we're saying we accept any arguments here. We're going to expect any arguments. And we want you, whatever arguments you get, we want you to return a user and nil. Now, I should say, before we go any further, I'm not a fan of mocking at all. I think it's an extremely fragile process that is extremely error prone. But these tests are written in a mocking style. And so given it's a language I'm unfamiliar with, I'm making some compromises here. And I'm going to go down this route to get something working in an hour. But normally I would steer well clear of the mocking style of tests because there's too much to go into here. But there are a lot of weaknesses with mocks.
So if I ask a question then?
Yeah, please do. Please do. I love questions.
Yeah. So how would you, I'm sure about the shows, but how would you go about this sort of testing without a mock?
I'm very glad you asked that. This is my hobby horse. This is the thing I'm probably the most passionate about right now, which is called Nullable architecture. And it's invented by a guy called James Shaw. Wow. Really? Nullable architecture? Programming? I don't know what I'm doing wrong here. I can just go to his website. So, I don't know. James Shaw. I think it's just jamesshaw.com. Yeah, this is it. And so services. Oh, it's best. This is it, right? So testing without mocks, a pattern language. So it's long and it's very detailed, but it's a way of getting accurate tests that read really nicely without mocking. If you don't want to use mocks, you kind of have, as far as I'm concerned, two other options. You can use something called VCR. Have you heard of VCR, Jake?
No.
It's a very odd little library. It's an interesting idea. It's used by, it came up in the Ruby ecosystem, but it's now got a library for every single language. And with VCR, what you do is, I'll just create another VCR.md. So in this world here, what you're doing is you've got object A and it's collaborating with object B. And object B is some kind of in this case, it's a server and it's a mock store. So get user by email, by username or email is what? That is kind of a repository. So it's going off and it's doing presumably a database request. Yeah, and then it's doing a bunch of other stuff. So in this particular case, VCR wouldn't be helpful. VCR is mainly for API requests. So you could use, okay, so the options really are, number one, if you're interacting with the database, use the real database. That's option number one. Use a test database that you tear down and set up every time. And you don't mock anything out. But then, of course, your tests are slow and potentially unreliable, maybe. This is how Rails does it and many other frameworks. Option number two is mock the database, which is what we're doing in this example here. Using a mock database, and we're saying, expect this, expect that, pretend that this comes back from the database. That is very, very fast, but it is brittle. Why is it brittle? Because the moment you decide to refactor this method, I mean, I don't know what the mocking libraries in Go are like. Some mocking libraries have these kind of checks where they will check before you can mock anything, if that method actually exists or not. But if you want to change that method, depending on the language, you may have to make scattergun changes all over the code base. And in the worst case scenario, you change the name of that and the mock doesn't even realize that the name has changed. And so you might be saying, expect this not to be called. And of course it won't be called, or it will be called, but you've changed the name of it. So now like the sands are shifting under the mocks, and now the mocks need to update. And every time your internal implementation changes, your mocking needs to change as well. So this is what we call coupling to implementation. Mocking tests that the code you wrote is the code that you wrote, which is like, yeah, I know it's the code I wrote because I wrote it. So I'm not a fan of this approach because it means that if you change your implementation, all of your tests are going to break and you need to go back and refactor, fix all your tests. And I've spent a lot of my life in this situation, added to which, if the real implementation changes slightly and your mock doesn't catch up, then the mock passes, so your tests pass, but your real system fails. So it gives you a false sense of security. So there's a lot of people that will tell you, when it comes to the database, don't bother mocking it out, use a real one. The third one is if you're talking about the database. So this is just database, and we'll talk about APIs in a second. APIs. The third one is something called nullable. Well, you can use nullable architecture. We'll come to that one in a second. And you can use, not VCR Copilot, you can use an in-memory database. So this is one of the advantages of the repository pattern in C# and various other languages as well, which means that you don't mock it out, but you give it a dummy database that only operates in memory. So in SQLite, for example, you can run SQLite either on disk or in memory. So you can kind of use the real thing, but have it in memory only, so it doesn't write to disk, so it's much faster. But there's all sorts of drawbacks to this approach. Like if you're using Postgres, you're not going to be able to do it in memory. So that then means you need to layer on a layer on top of Postgres, which can mean the repository pattern. That means you have an object that shields you from the details of the database. And that object can be swapped out for an object that has exactly the same interface, but it operates only in memory. But of course, there's a layer there that you need to keep up to date with the database, and that can be really, really hard work. And then finally, I'll just renumber these. You've got nullable architecture. And nullable architecture is kind of difficult to summarize in a few sentences. But basically, you have a programmable stub deep in the depths of your infrastructure layer. So you will have the application code here. And normally the application code would, that's the repository model. It would call the repository, and then the repository would deal with the database. Instead of doing that, maybe you have the repository, maybe you don't, but you have this very, very thin shim here, which is an infrastructure wrapper. Structure wrapper. It's very, very thin. And it really, in the case of a database, it might be, this db.execute, db.query row, right? That would be a perfect example. You'd have this infrastructure wrapper that would wrap the database, and it would have a very, very low level interface like query row. And all that's great. And then when you're in your test mode, you swap this out for a null infrastructure wrapper. And what that does is it never ever talks to the database. And so as far as the rest of your application code is concerned, it's still talking to a database, but you null it out, and it's a little bit like the in-memory one, but it's just further down the stack. So you have this kind of in-memory null infrastructure wrapper. You can use this, it's actual real code, it's real production code, but it pretends like it's a database. And that means you can query it, and then in this null infrastructure wrapper, you can just have a variable in memory that's accumulating all the queries that it gets and then sending back responses. So it's almost like you can program this to act like a database. Now, some people think this is an absolute bonkers idea, and it is quite a lot of work to write one of these null infrastructures on infrastructure wrapper. And there's an embedded stub, and there's a lot to learn around it. But the advantage is the rest of your program doesn't have to know that it's using this null infrastructure wrapper. It's really fast. There's no mocks needed. And then you have a whole bunch of tests that run on the real one and run on the null one and make sure the behavior is exactly the same, precisely the same, so that you can depend on this acting like a database, but it doesn't really write anything to disk. That was like 10 years of obsessing about mocks in like 12 minutes or something. So it's quite a lot to take in, I appreciate. What questions do you have about that, Jake? Surely you must have some questions now.
Yeah, it's interesting.
I'm definitely going to do a live stream on null infrastructure and nullable infrastructure, and I've already had somebody ask me that specifically. So Inam, if you're watching this, we will do a stream on nullables, and I will show you how I'm using it in one of my real projects, one of my personal projects that I'm taking quite seriously now. Sorry, what were you going to say, Jake?
I'll wait for the nullable architecture video and let you keep cracking off.
Awesome. So then for the API one, just to kind of complete the picture, when you've got external dependencies, normally they fall into these two categories. There's like caching layers and various other bits and pieces, and there's like, eventing APIs and things like that. But normally it's some kind of an external API. So it's like Stripe or Big Marker or something like that. You can mock the API, which is the same deal as this. Expect this HTTP endpoint to receive this and return X, Y, and Z. You can use an in-memory API, I guess. It wouldn't be SQLite, of course. You can use VCR. You can use Nullable architecture, of course, or you can use this thing called VCR. And VCR records external API requests, and then it records them to JSON files on disk of all things. And then you say to VCR, the next time this test plays back, read the JSON from disk and imagine you're interacting with a real service. But it basically mocks and stubs out all the, it doesn't mock out, it stubs out the external dependency, the API, for you in this kind of JSON, this funny formatted JSON cassette. Because, of course, the analogy, it's a VCR. So, of course, the thing that records the requests and responses has got to be a cassette. So those are your main options for testing. And they all look kind of like, well, you know, there's all of these trade-offs, and but they're all kind of much and muchness, right? They're all trying to do the same thing. But believe me, once you actually get into a big code base and you're locked into one of these approaches, you soon learn if it's the right approach or not, and you soon get quite frustrated. Anyway, so we're going to be doing this approved payment request. And let's go back to our test here. We're using this mocking, and we're saying get user roles and return an empty user role and nil to imply that it's worked. And then we make the API request approval. We require no error, and then we want the status to be 401. Now, this is interesting. It says expected call to this because there are no expected calls for that receiver. That's interesting, isn't it? Expected a call to all of this stuff at this line. So line 391 in payments. So what I find is really prevalent in engineers is they look over an error like this and they just go, oh yeah, oh, it's that method, that's the problem, and they don't read it. So it's really important to thoroughly read this stack trace. And it's not formatted the best, I have to admit. So it's a bit confusing. It's line 391 that it's pointing to first. So let's go to 391, which is here. Approve payment request with audit. Interesting. So we know it's hitting the approved payment request. It's getting past all of this stuff here. And then it's getting down to here and it's saying, what is it saying? There are no expected calls of the method. Okay. I think this is the mock saying, I like, you've not said that I expect one of these requests, and now I've hit it. I can't go any further for you because you're not stubbing it out. So what I can see is there's a difference between our two tests here. And this one here is creating random payment request and expecting this method to be called. And hey presto, that's the same method down here. So I think we're just going to copy and paste that up there and rerun it and see what happens. Okay, that is actually the error message we want. So we want to make that pass now. Now, the question in my head is, should we write another assertion? Because this is pretty hairy. It's just saying you expected 401 got 200, but it's not telling me why. But I'm just going to leave that one on the stack for now. We've already got one failing test, which is all we really need to do to get to for test-driven development. The failing phase is get a failing test, and ideally the test failure should be readable and should tell you very clearly the difference between what it expected and what it got. So I think this is probably good enough. So we now need to make that pass. So it's a bit of a funny one because we are being more strict in order to make something pass. We're not really adding a feature. We're more like fixing a defect, really. So we're in the roots, and the question is, what's the easiest, quickest way of getting that test to pass? Not the best way, but the quickest way. So I remember seeing this code base somewhere, get user roles. So they're the expects, but I want the actual production code. Where is it calling get user roles? Oh, it's a capital G, isn't it? And we want a dot. That's okay. This is interesting. So current user middleware. This is the kind of thing I was thinking. So this is getting the current user roles, and it comes back with an array, and it looks like that array is an array of numbers, and those numbers relate to user roles. And you can see it says user roles are, and it's printing out. And what I noticed back here was it prints out an empty array. So it has no user roles, and it's just passing. So when there are no user roles, it shouldn't pass. So what we want to do in this endpoint is get the user roles and say if they are, well, I mean, the simplest way of getting this to pass would be to say if they are empty, if the user has no roles, then just give them a 401. Don't let them in. So server.store.get user roles. And here we're stubbing it to be, I think that's an empty array of user roles, I think. So in the production code, we want to get those user roles somehow from this thing called the context. So let's see how the middleware got that. Is C context? Please tell me C is context, because that'd be awesome if it was. Yeah, cool. So if we just say service.store.get user roles, server.store.get user roles, and we'll pass in the context here, CTX. And this is interesting. Why does it want a user ID here? Oh, sorry, the user ID. Yeah, so the current user. How do we get the current user? I think it might be on context. Eesh, I don't know. So I'm going to go looking for a situation where I need the user ID, which is in this middleware. This middleware is the closest thing we have to what we want. Oh, I see. So you've got to fetch the user first, and then get their ID, and then get ID and pass that into get user roles. And that will allow you to see what roles the user has. Okay, fair enough. So it will be seen to be a bit of a waste to do this twice or 3 times. So I'm just wondering what it does with user. Does it store it somewhere? Ah, that's interesting. C is context. So it's setting, you can do this .set thing apparently, which looks like it's setting a key and a value in the context. Can you summarize what I'm doing here, Jake? Do you kind of get it? And if so, can you kind of explain it in your own words?
I think instead of calling those methods, you're looking to just pull it off the request. I think it's set on the request, this context request context. So I think you're looking to grab it off there.
Yeah, exactly. I'm looking to grab it off the context because this middleware is already setting it. And we know we need user ID to fill in this little gap here. So if we do context.get, okay, and it was user ID, okay, and it's kind of filling all the types in for us. Why is it I've got a red squiggly line? Let's try and get rid of that nonsense there. Cannot use as a type int64. What if I cast it to int64? Nope, it doesn't like that either. I don't know how to cast stuff in Go. This is possibly where we need to break out ChatGPT. Cannot use context get as the type int64. Multiple value. Oh, I know what it is. It's what I was lecturing you about just before. Whenever you do a get, it's going to return, if we hover over here, yeah, a value, any, and whether exists a Boolean. So you see that value any exists bool in that tuple, in those brackets. That's what it returns. So the fact is it was returning 2 objects. And so Go is just saying, no, you can only have one thing there. What are you talking about? Okay, so we want the value. So the value is going to be user ID and then exists. And we'll make it equal to that. Still red, unused variable. Okay, I can deal with that. We don't care whether it exists. We're just going to ignore that. And we're going to pass the user ID in here. What does it not like now? Does it need typecast now? Change second parameter of method specification. No, we definitely don't want that. What we want to do is say, hey, this is an int64. No, I'm just guessing now. Let's see if somewhere else in the program we've got context.get. How have they done it elsewhere? Nothing found. Interesting. Probably because I'm searching for a massive multi-line string. Ah, okay. Interesting. So I'm a big fan of, if you're stuck, just look at the existing code base and see what else there is. Payments.go. That's the code we wrote. But here in users.go, they're doing exactly what we want. Ah. Oh, that's very strange. So you've got to somehow unwrap this user ID by doing .int64. Wowzers. Okay. And then if I do user ID int, it's happy now, except it's not 100% happy because there's an unhandled error. That's fine. So because Golang is absolutely an awesome IDE, you just do that and it puts the error check in for you. And then it just tells you the roles you're not using yet. Okay. I don't understand this syntax, but I'm just going to copy it because that's what's there already. What questions do you have apart from why do you have to do that in Go? I can't answer that. We just mindlessly copied it from somewhere else.
No questions.
No questions. Awesome. Right. So if there is any error, then we're going to return, and we will write a test for that eventually, but we've got 10 minutes left. So we just want to say, if roles are empty, then return an exception, basically. Sorry, return this kind of, this is how you return a 400 error response, it looks like. Oh, what? Oh, there was a method to do it already. Ha, that's hilarious. Oh my gosh. Okay. So we've just wasted a whole bunch of time when we could have just scrolled down a little bit and it was right there. Oh dear. That's not great, is it? So approve petty cache, where were we? Approve payment, create payment request. It wasn't create payment request, it was approve payment request. Update, approve, right. So we'll paste that in. We'll get rid of all of that nonsense. And then we can delete that. In fact, we'll just put that right at the very top. And no, it still doesn't like it. Let's just unwind to what we had before. Simpler. Okay. Right, so that was working for us. So if that'll do me. Yeah, that seems reasonable. Now, it's not really the 0th role. We want it to be if it's empty. Don't know how to do if is empty in Go. If, oh yeah, there we go. Awesome. Isn't Copilot a wonderful thing? So I'm just going to run the test now and see if we've achieved our objective. Oh, no new variables on left side. Doesn't like that. I think it's because we've already defined user ID int up here. Maybe if we just delete that and maybe even delete that. And now it's saying it doesn't like this. Cannot use, because it's int 64 versus int 32. So if I just do that. Okay. Convert to int 64. Okay. Okay then. So we're still failing. Unexpected call to get user roles. Because it's already been called the max number of times. Right, because get user roles has already been called. Yeah, so if I do that, maybe. Invalid memory address or nil pointer dereference. Oh gosh. That's not great, is it? What have I missed? What have I missed? It is reusing error there. And error is nil. So that's why it's doing it, I think. I want to look at another example of. Right, excellent. So we can just replace this error response. Do you see what's happening here? Do you see why it's failing?
Not quite, actually.
It says invalid memory address or nil pointer dereference, which is a very, very long-winded way of saying it's, again, it's the key is to reading the backtrace, going down to the first thing that's in your code that looks vaguely familiar. So it's on this line, and it's saying nil pointer dereference. So I'm going to look at the argument that's been passed in, because that's a variable. On this line, we've said if the error is not nil, then return. So if we get to here, the error must be nil because this operation was successful. But because I've copied and pasted this from another part of the code, it had error assigned to something else. And right now, error is nil. So when we pass in nil to that, it crashes. It can't deal with ERR being nil because it's not expecting it. And if we look down here, it's setting ERR here, and then it's saying, if the error is not nil, then do this. So it's only taking ERR there to convert error into some kind of error response. So we don't actually need to do that here. It looks like we can just give it a string and it'll be happy. So we can just do that. See what happens there. And boom, we're passing. And just like that, we have our passing test. And what we can do, because we've got 5 whole minutes left, is now check the response is, you don't have permission to access this resource. So require equal. Now we need to do something here. And it's response dot. We kind of want the passed body is the only problem. Let's just see what happens with that. Expected something, and we actually got, oh my gosh, a whole bunch of noise. This might be a bit of a bridge too far. Let's see if there's any other examples of it asserting on the body of a response. Extract payment request from response. So, oh, wow. Okay, so it's this. You've got to read all response body, and that gives you the body bytes. And then you've got to unmarshal the body bytes into this if you want to parse a JSON. Now we don't, and I'm hoping it's just going to be a string. So I'm hoping we can just copy and paste this. So body bytes is all of that jazz. And then we expected the body bytes to be that. Let's see what happens. Hey, look at that. We expected something. This is a trick I often do, Jake, if I'm trying to figure out how to actually get a failing test, is that I'll write a string with just any old nonsense in, just to move past it. And when I see the any old nonsense string not match this string that we want, now I've got some fast feedback to tell me I'm on the right lines. And now I can adjust this to something that we actually want. But it does look like it's a bit weird because it's got these quotes inside. So that might trip us up. Yeah, you see, I don't know why it's got quotes inside. That seems a bit strange to me. So I think we'll need to do that. If we weren't right at the end of the string, I would, at the end of the stream, I would fix it. But there we go. And then this user roles are, we really need to get rid of that from the test output. That's not very nice. But that's for another day. And then what we should find is this test now should actually fail if we've done our jobs right. Okay, it's calling this a number of times, so we'll just paste it in. It's getting confused. Right, failed to unmarshal, cannot unmarshal string into a go value of payment request. Yeah, okay. So that's because the response, oh, that's really interesting. Yeah, so whoever's written this test hasn't checked the status code first. So it's tried to extract the request from the body of the response, the payment request, but it's just going, I don't know, like I can't do it because it's not a successful response. So what we actually need to do is test, is it a status code okay first? And then try and pass the body if it is okay. Otherwise, if this fails, it'll stop here. There you go. So that's what we expect, isn't it? It should be a 401 because it's just any old user. So we're going to have to change this test, and we'll do this next stream. We'll change this test to be when the user is an admin and makes a payment and everything, then it should be successful. It should go through. And instead of doing a get user role and coming back with just an empty user role, we'll come back with an admin user role. And then it should be okay. And then at that point, we can, I mean, look at all of this hairy nonsense here. This is seriously horrible. This should all be a middleware, but I just wanted to get something working. So we've got our new test that's working. Our existing test that is wrong for the old behavior is not working, but we'll fix that next stream. And then we'll do some neat refactoring to shove all of this into some middleware so that it's reusable and it's not cluttering up this approved payment request function. Any questions that you have there, Jake?
No, I've learned some stuff today about especially about the mocking strategies and different types of API strategies. You've seen what you've done with the test. So no, yeah, it's good.
Cool. Okay, thanks everybody for watching, and tune in next week for another Software Design Simplified, where we will be continuing with this example. We'll probably continue with this for another couple of live streams because there's quite a lot of refactoring that we can do here, quite a lot of behavior change we can do here, and it's all good. Okay, I will see you next time. Bye, everybody.
Bye. See you, John.
See ya.
Thank you. Bye.